Yes, dear students, in previous class we were discussing the alternating series test. What is alternating series test? If sequence Zn be a decreasing sequence of positive reals with the limit Zn equals 0, then the alternating series sigma minus 1 power n plus 1 Zn is converges. So, by using these arguments, now let us discuss the convergency or divergency of some series. What about the convergency of sigma minus 1 power n plus 1 into or minus 1 power n plus 1 by n plus 1? So for testing here, let us Zn equals 1 by n plus 1. So what about the sequence? Is it decreasing or increasing? For n is any natural number, surely the series is a decreasing series. So the sequence is a decreasing sequence. Why? 1 by n plus 1, so it is Z1, 1 by 2, Z2, 1 by 3, and so on. Or moreover, generally, what is Zn minus Zn plus 1? Zn minus Zn plus 1 is 1 by n plus 1 minus 1 by n plus 2. So it is, by taking LCM, it is n plus 2 minus n plus 1. So n plus 2 minus of n minus 1 divided by n plus 1 into n plus 2. So equals n and minus n cancelling each other. So it is 1 by n plus 1 into n plus 2. So 1 by n plus 1 into n plus 2 is a positive quantity. That means Zn minus Zn plus 1 strictly positive means Zn strictly greater than Zn plus 1 for all n fallen n. So that means sequence Zn is a decreasing sequence. Okay, sequence Zn is a decreasing sequence. What about the limit Zn? When limit Zn equals limit, what is Zn? 1 by n plus 1 equals 0. So Zn is a decreasing sequence of positive reals as well as limit Zn equals 0. So by this alternating series test, we know that, or we can conclude that sigma minus 1 power n plus 1 by n plus 1 is a convergent series. Okay. Yes. What about the convergency of sigma minus 1 power n plus 1 into n by n plus 2? Is it converges or diverges? So here, it does not converge. Why? Because you can choose Zn. Zn equals n by n plus 2. Zn equals n by n plus 2. So what is limit Zn? Limit Zn equals limit n by n plus 2. Limit n by n plus 2 means it is limit 1 by 1 plus 2 by n. Taking n as common in numerator, so the denominator, and you can cancelling n, so it remains 1 plus 1 by 2 by n. So its limit is 1. Enough. So limit Zn equals 1. Moreover, what is Zn minus Zn plus 1? Zn minus Zn plus, so it is differs from 0. Okay. So Zn minus Zn plus 1 is n by n plus 2 minus of n by minus n by n plus 3. Okay, Zn plus 1 is n plus 1 by n plus 3. So equals, it is n plus 3 into n. So yes, n plus 3 into n minus n plus 2 into n plus 1 divided by this denominator. So this should be negative. That means Zn less than Zn plus 1 for all n fallen n means sequence Zn is an increasing sequence. So sequence Zn is an increasing sequence with limit Zn is strictly differs from 0. So by alternating series test, sigma minus 1 power n plus 1 by n minus 1 power n plus 1 into n by n plus 2 does not converge. Okay, by alternating series test, sigma minus 1 power n plus 1 into n by n plus 2 does not converge. Enough. Now, consider another series What about the convergence of sigma minus 1 power n plus 1 of log n by n? Sigma minus 1 power n plus 1 into log n by n. So for testing, put a Zn equals log n by n. What is limit Zn? Here limit Zn equals 0. Limit of log n by n, limit log n into limit 1 by n, so it is 0 itself. So limit Zn equals 0. What is Zn minus Zn plus 1? So Zn minus Zn plus 1 is nothing but it is log n by n minus log n plus 1 by n plus 1. So clearly it is n plus 1 into log n minus n into log n plus 1 all divided by n into n plus 1. So clearly it should be positive. N plus 1 log n minus n log n plus 1, that is a positive quantity. So clearly Zn is strictly greater than Zn plus 1 for all n following n means sequence Zn is a decreasing sequence and limit Zn equals 0. Therefore, by alternating series test, sigma minus 1 power n plus 1 log n by n should converge. Okay. So, now consider another one. Let us consider x by 1 plus x. X by 1 plus x minus x square by 1 plus x square plus x cube by 1 plus x cube plus etc. What about this one? Is it converge or diverges? With x lies in between 0 and 1. The condition is crucial where x lies in between 0 and 1. So the series is of the form sigma minus 1 is an alternating series. The each term minus 1 power n plus 1 xn is all positive or all negative. So minus sigma minus 1 power n plus 1 x divided by 1 plus x power n. So of the form sigma minus 1 power n plus 1 x by 1 plus x power n. So what is Zn? Let Zn equals x by 1 plus x power n. What is limit Zn? Limit Zn equals limit it is x power n. So it is limit x power n by 1 plus x power n. Zn equals x power n by 1 plus x power n. So limit Zn is limit x power n by this one. That equals it is limit x power n by limit 1 plus x power n. Since x lies in between 0 and 1, what is limit x power n? Limit x power n should be 0. Therefore, this limit Zn equals 0. Now, what about Zn minus Zn plus 1? Here, Zn minus Zn plus 1 is Zn minus Zn plus 1 is what is Zn? X power n by 1 plus x power n. Minus Zn plus 1 is x power n plus 1 by 1 plus x power n plus 1. So, that equals, it is x power n into 1 plus x power n plus 1 minus x power n plus 1 into 1 plus x power n all divided by 1 plus x power n into 1 plus x power n plus 1. Okay. So, that equals x power n into 1 and x power n into x power n plus 1. So, if you open the bracket on numerator, it is x power n plus x power n into n plus 1 means x power to n plus 1. Okay. minus x power n plus 1 into 1, x power n plus 1, so minus x power 2n plus 1. So plus x power 2n plus 1 cancelling each other, that equals x power n minus x power n plus 1, so it is x power n into, come on, it is x power n into 1 minus x divided by the same denominator. So it should be positive. Okay. So it is x power n into 1 minus x. Since x lies in between 0, this is because of x lies in between 0 and 1. So 1 minus x is positive. So x power n into 1 minus x is positive. So the ultimate quantity is positive. Means Zn minus Zn plus 1 should be positive. That is Zn greater than Zn plus 1. So sequence Zn is a decreasing sequence with the limit Zn equals 0. So by alternating series test, the given series sigma minus 1 power n plus 1 x power n by 1 plus x power n, it should be converges. Okay. Now again test the convergency of 1 by 1 power p. 1 by, consider another series. It is 1 by 1 power p minus 1 by 2 power p plus 1 by 3 power p minus 1 by 4 power p plus 1 by 5 power p minus etc. What about the convergency? How to check this one? So the series is of the form sigma, it's again an alternating series, sigma minus 1 power n plus 1 into 1 by n power p. Okay. So what is Zn? Let Zn equals 1 by n power p. So surely 1 by n power p should greater than 1 by n plus 1 all power p. Okay. 1 by n power p always greater than 1 by n plus 1 all power p for all n fallen in. That means what is 1 by n power p? Zn. So Zn should greater than Zn plus 1 for all n fallen in. So that means limit Zn, sorry, secant Zn is a decreasing sequence. Enough. And what is limit Zn? Limit Zn equals limit 1 by n power p. Limit 1 by n power p is again 0. So again secant Zn is a decreasing sequence. Secant Zn is a decreasing sequence. And limit 1 by n, limit Zn equals 0. Therefore by alternating series test, surely we can conclude the given series is converges. Okay. So now let us discuss the another test for convergency here for the partial summation formula. What is partial summation formula? The partial summation formula, it is known as Abel's lemma. A-B-E-L apostrophe S. Abel's lemma. This is nothing but the Abel's lemma is the partial summation formula. So this lemma states that let x equals xn, x equals sequence, x equals xn and y equals yn are any two sequence of real numbers. Let the partial sums of sigma yn, partial sum, let Sn be the partial sums of sigma yn with S0 equals 0. Sn be the partial sums of sigma yn with S0 equals 0. Then if m greater than 1, if m greater than n, then sigma, then the partial sum states that, the partial sum formula states that sigma k ranges from n plus 1 to m xk yk equals xm sn minus xn plus 1 sn in plus sigma k ranges from n plus 1 to m xk minus xk plus 1 xk minus xk plus 1 into sk. So this is partial sum formula. This is the partial summation formula. The partial summation formula states that x equals xn and y equals yn are the sequence of real numbers. Let Sn be the partial sum of sigma yn with s not equals 0. And if m greater than n, then sigma k ranges from n plus 1 to m xk yk equals xn sn minus xn plus 1 sn plus sigma k ranges from n plus 1 to m xk minus xk plus 1 into s. Okay. How to prove this one? What is Sn? Its proof is we have Sn. Sn be the nth partial sum of sigma yn. So what is Sn? Sn equals y1 plus etc. plus y. Agreed? Okay. What is Sn minus 1? So Sn minus 1. Sn minus 1 is y1 plus etc. plus yn minus 1. So what is Sn minus 1? Sn minus 1 equals yn. Clear? Okay. That means yk equals, what is yk? So yk equals sk minus sk minus 1. Sn minus 1 is yn. Therefore, yk equals sk minus sk minus 1. Okay. Therefore, our requirement is xkyk. What is xkyk? Xkyk equals xk into sk minus xk into sk minus 1. Clear? Therefore, that means sigma k ranges from n plus 1 to m xkyk equals sigma k ranges from n plus 1 to m xk sk minus xk sk minus 1. Then that means left side equals, then open this bracket or as a distributor this k. So it is xn plus 1. When k equals n plus 1, it is xn plus 1 sn plus 1 minus, here it is xn plus 1 sn. Okay, k minus 1 plus second term k equals n plus 2, so it is xn plus 2 sn plus 2 minus here xn plus 2 sn plus 1. Okay, plus etc. plus when k equals m, it is xm sm minus xn sm minus 1. Clear? That equals, here there is minus xn plus 1 sn. So it is minus xn plus 1 sn. Now, xn plus 1 sn plus 1 minus xn plus 2 sn plus 1. So, plus sn plus 1 into, but I get xn plus 1 minus xn plus 2. Plus sn plus 1 into xn plus 1 minus xn plus 2. Again, there is xn plus 2, sn plus 2. Here sn plus 2 into what remains xn plus 2 minus xn plus 3. Okay, plus etc. plus etc. plus sm minus 1. Sm minus 1 into what I get xm minus 1 minus xm minus 1 minus xm. Okay, what's the only one term remains there, it is xm sm. Okay, right. So that equals xm sm minus this one minus xn plus 1 sn. Xn sm minus xn plus 1 sn plus sigma k ranges from n plus 1 to m. Sigma k ranges from n plus 1 to m. What I get? It is sk into, it is xk minus xk plus 1. Okay, that is what we are accusing. So this is Abel's lemma. That is, if x equals xn and y equals yn are any two sequence of real numbers, and Sn be the nth partial sum of sigma yn with s not equal to 0, then if m greater than n, sigma k ranges from n plus 1 to m. Xk yk is nothing but xn sm minus xn plus 1 sn plus sigma k ranges from n plus 1 to m xk minus xk plus 1. Here we use the nth partial sum of sigma yn. Sn is y1 etc. yn. Sn minus 1 is y1 plus etc. plus yn minus 1. So yes, yn is nothing but sn minus 1. That means yk is sk minus sk minus 1. So xk yk, take the product. Then after taking the summation, then after some manipulations, we will have sigma k ranges from n plus 1 to m xk yk is nothing but xm sm minus xn plus 1 sn plus sigma k ranges from n plus 1 to m sk into xk minus xk plus 1. That is what we recurse here. Okay, this is Abel's lemma, that is partial summation formula. Clear? Right.